Welcome to The Farmer Was Replaced, a surprisingly fun Python idler game where we'll be using kind of a simplified version of Python to solve some real programming challenges in kind of a chill, fun way, using this little drone to harvest and farm some stuff. I should probably mention this isn't maybe my first time going through at least part of this game. I was previously recording a different kind of playthrough of this, but after uploading the first, I think, part of that, it was pretty clear that the audio setup left a lot to be desired. So we've got a revamped audio kind of kit here. So without any further ramblings on my part, we'll go ahead and start. And we'll get this getting started window. Just some really simple kind of introductions to the game. Does you had to go to your first program. We got our run button, we got a step through function. So this will run only one step of the code. This will be helpful for debugging and that kind of stuff later. We got harvest, do a flip, and we might also have the ability to pet the little pig that's flying around here. Since we only have harvest, we don't have any like loops, conditions, anything. We're really just write one line of code, run one line of code. We're going to write our harvest, if I can spell. You're going to notice that's a common theme. Whenever I am either recording myself or if somebody's watching me type, I suddenly can't type to save my life. But we're just going to start with these three little harvest calls. Again, we can't loop it, so we're just going to write it 3 times. And there we go, we got 3 hey. We'll run it one more time. And then this up here is going to flash, which will give us our unlock tree, and that'll give us a while loop. So while will basically just say, do what's in the loop until the condition is false. We are going to do the old, tried and true, while true loop. And we're just going to call our harvest function. Go ahead and run it. Get a little bit more hay, and now we have a few things we can do. We can unlock some speed, we can unlock hats, because that's fun. We'll go with speed for now, and that'll introduce something new. We're going to see that we're not actually getting any more hay, but we do have this new can harvest function. Here we're just going to say if can harvest, and that's a function, so we're going to call it. And that'll give us a true or false back. If it gives us a true, then we're going to harvest. If not, we're kind of just going to do nothing. And if you want to, you can put a little else here. We'll just say like do a flip. Alternatively, you could do, this one's kind of fun, pet the piggy, because we should have that available to us now. So to harvest, it'll go pet the pig. Harvest, go pet the pig. Obviously that's really slow, so we're not going to keep that. Harvest, do a flip is a little bit faster. Doing a flip is just a way to stall, to be honest. I don't know about Python specifically, but some languages, if you have this while true loop, it'll just try to go through this loop as fast as it can. Interestingly, if you've ever played a video game and you've had the main menu burn up your graphics card more than the actual game does, that's probably what's happening, is your graphics card can produce so many frames because the game's menu is really simple that it's going like 1,000 frames per second. Maybe we could be limiting our frame rate here. We could find ways to slow the computer down when it's going through this loop, but within the game, this doesn't actually matter. So we'll get a little bit more of that going. We have a couple of options. We can do an expansion. We can buy some hats. We can get some plants. We're just going to move on. We're going to expand. So we have a 3x3, and we've unlocked a move function. Basically, we're just going to be over a tile. If we can harvest, we can harvest it. And then regardless of whether or not we've harvested, then we're going to move up, or move north in this case. Also, I didn't actually open the documentation here, but if you're on the top tile here, so now that we're on this top tile, if I move north again, you're going to notice we're just going to wrap right around to the bottom. There we go. And you'll see we've wrapped around. So we don't need to track our position. We don't need to do like north, north, south, south, north, north, south, south. Go ahead and get that started, and then we're probably going to buy, I think for now, plants are going to be a good thing to unlock. And we also get this clear function now. We can reset the farm, and we can automatically move ourselves to 0, 0. All right, we'll go ahead and stop this. Let's start with a clear. It'll be a good way for us to make sure that we're always starting on the origin. And then we're going to do each of the 3 rows. And this will be a lot less hard-coded later once we unlock the things we need to do it. I'm just going to add some comments just to keep track of things. We're going to actually need this move north everywhere. As a programmer, you would see something like this and say, hey, I feel like I'm writing the same code. This would be a great opportunity for, if you see yourself writing code that feels really repetitive, it's a great opportunity to use something like a function, a loop, or something to, remove the duplicated code, even if it's just a few lines like this. Okay, so we have our 3. I just need to move this comment, and then we're going to do a plant. And now we can see it's working okay. We've got 17 wood, about 200, just shy of 200 hay, it appears. While that runs, we can go to our unlock tree. Now we have speed. I think this is going to be really helpful. We have another expansion. I think speed is going to be the most helpful to start. I'm going to change one thing. I think we can get more than one harvest out of this bottom tile. Just spend a little bit less time going over those bushes, I suppose. Okay, back to our unlock tree. I think let's get grass. The goal for part 1, I believe, like kind of looking at the unlock tree here, and while our program has been running for a minute, we're going to do operators, carrots, and trees, and we're going to get some basic kind of grid layout stuff going. We'll go ahead and get operators. I'm going to go ahead and stop this so it doesn't run for too long. Should point out that the goal of the first part is not to optimize for speed. Really just enjoy the game on the first way through, and then if we do any like leaderboard runs or things like that, then we'll get really into the nitty-gritty of optimizing and all that good stuff. Okay, so we got our operators. We're also going to expand. I think it's just a good opportunity to do both in one, because we're already going to be cleaning this up a little bit. So we just unlocked a 3x3 grid, and we have operators now. So we could use some cleaner Python to do this. I think what our plan is going to be, we will do grass on rows 1 and 3, and then bushes on row 2. Yeah, that'll open us up for replacing one of the grasses with carrots when we unlock it, which should be here in just a moment. So we're going to do 2 for loops. Basically, a for loop is just going to loop over like a list of things. We're going to do a loop for our x and y coordinates, and then we'll start using some if comparisons to see if we want to plant a patch of grass, or if we want to let grass grow, or if we want to plant a bush. We're going to go for y in range, get world size. And this get world size is a function that they kind of give you somewhat quietly. Basically, it'll just give you the dimension of your world. So for 3x3, calling get world size is going to give us a 3. It won't be like a 3 and a 1 like we had before with 3x1. Next, we're going to loop in our x direction. So for x in range, get world size. Now, importantly, we are only tracking these y and x as a variable. We can't forget to move, because the x and y has nothing to actually do with the drone itself. I also forgot those, and that's an extra parenthesis. Okay. So basically, just because we've called it x and y, it has no bearing on the actual drone. If we forget to call move to it like north, east, west, or south, or whatever, the drone will not move, and it'll be nice and confusing. Now that we're inside the loop, we're going to do a quick check. So if y is equals 2, this is the bush one. This is the only one we're doing something special for. So for now, it'll be the only if. We're going to say if, actually, correction. Everything is going to if can harvest. Cool. And we're only going to do this after we've harvested. Then we're going to plant dot bush. So we're going to plant a bush only if we're in the second row and we've just harvested. Like if we've already planted something, obviously we don't want to plant over it. Since we're in our X loop, we're going to move east. And then at the end of our Y loop here, we're going to move north. Obviously, you can call a variable X and I could move north there and it'll work just fine. But should go without saying that we should keep these things in sync with, if we're calling it X, it should actually be our X position. Okay, that being said, just did a whole ramble about how we should be calling things exactly what they are. And I can't help but notice that my y equals 2 didn't do what I wanted it to do. And I think I kind of did a silly. I'm stupid. Okay, I didn't tab these into the right levels. That's embarrassing. So that is not doing what I expected it to do, nor is it doing what I wanted it to do. It is in fact just doing what I told it to do. So we'll go ahead and try this again. Now we should be actually on the correct y equals 2. And our y variable should be tracking what we actually want it to be tracking. So this will clear everything out, and then we'll see how this works. There we go. Now we're going to see we're planting bushes on y equals 2. Also, one other little thing I can mention is I was saying row 2 would be bushes and 1 and 3 would be grass. And then when I typed in 2, I realized that I hadn't 0 indexed it. What I originally said would be that rows 0 and 2 would be grass, and then row 1 would be bushes. However, I don't think it makes too much of a difference. The idea is we're still doing 2 and 1 with bushes. So I not too much of a need to correct that. Anyway, we're collecting some resources quite nicely. Let's go back and check our unlock tree. So we're going to go ahead and do carrots. And we'll see that we get a new variable called grounds.soil. And then we have a till function. Let's go ahead and stop our main. So we have this grounds.soil. It's a good thing to know for now, soil and grassland. It won't be until we get census that we can actually check what the ground is. So for now, we're going to rely on our own ability to keep track of it. Yeah, if we try to till and the ground is already soil, it'll go back to grassland, which is a problem. So we can't just check if it's something that we should be planting carrots in and then till it. Every other time, it will not be able to plant anything. And that's not great. What we can do, though, is we can add a little setup step here. And this is not like a technical term, but before we enter our while true loop, we can perform some setup. And then this will be like our actual, like, So we've broken it up into 2 sections. We have our setup and we have our actual like farming. I don't know why I put such a weird comment in there, but that happened. So for our setup, we're simply going to we're going to make this bottom. Our row 0 is going to be carrots. So we don't really need to do anything. Clear is going to bring us to 0, 0. So we're going to say for x in range, get world size. So for each x coordinate, we're going to till the ground. We're going to plant an entities.carrot. And then we're going to move east. Before we actually enter our main farming thing, we're going to stay on row 0, and we're just going to till the ground on each tile, plant a carrot on each tile. And then, since move east is the last thing that'll happen, we'll start here, till, plant. Move here, till, plant. Move here, till, plant, and then move, which will bring us right back around to our origin. From there, we can start our main loop, which we'll just need to tweak a couple of little things. Notice that our harvesting thing is based on the ability to harvest something below it, which is why it's important that we plant a carrot up here. And we're going to just simply add if y equals 0, plant entities.bush, or sorry, entities.carrot. And I don't think I spelled entities right. Okay. All pretty much the same. Row 0 is carrots, row 1 is bushes, row 2 is going to be, correction, row 0 is carrots, row 1 is grass, and row 2 is going to be bushes. All right, we'll go ahead and give this code a run. We should clear everything, planting some carrots. So far, so good. And you'll notice it went back over that row 0 twice in that first call, and that's just because it begins. Obviously, our while loop will have it go over this row 0, and our setup will have it go over row 0. But we seem to be doing pretty good. We've got 3 rows, 3 different crops going. And I think we're going to change this up a little bit. We're going to say if y is less than or equal to 1, plant an entities.carrot. And then we're going to add one more loop out here for a while loop. So for y in range 2. Okay, so we have our setup function. It's going to go over the first 2 rows. It'll go over rows 0 and 1. And now we're going to step into our while loop, which will run everything. And we'll say if y is less than or equal to 1, plant a carrot. If y equals 2, plant a bush. And that's mostly just because of how much of a lead we have with our hay over our wood. Actually, so after this loop, last thing is I need to move south. Since we're going up a row, we're going to end up on 1, 0 here, or 0, 1 rather. We need to move south, so we go back down to 0, 0. Ooh, something happened here. Oh, yeah, we are going to call this move north twice. See, now we're on 1, 0, so we need to move south twice. So we'll go ahead and run this again, and we'll see how this goes. So far, so good. We've planted 2 rows of carrots. And then we're planting bushes on the third row. All right, let's check our unlock tree again. Maybe let's go ahead and expand, and then we can also buy trees. And then I think that'll be kind of our target for this first part here. So we have a similar kind of setup here. Okay, so I definitely should have brought this up first, but this is the documentation page for trees. Trees are going to be a far better way to get wood than bushes, as they give 5 wood each. And like bushes, they could be planted on grass or on soil. However, they do come with kind of a challenge, where trees next to each other are going to take longer to grow for every tree in an adjacent tile. And this is not including diagonals, which means that if we plant trees on every single cell, it'll take 16 times longer to grow. So we obviously don't want to do that. So what we'd like to do to maximize our trees is have a nice little checker pattern grid here. And just for the sake of simplicity, I'm going to temporarily remove our setup function. Now, we should do a little bit of planning. I think, obviously, if we can plant a tree, like if we're on one of those checkerboard tiles, we're going to plant a tree. That's just going to be the default. If we're not on one of those, I think we can keep our row grouping together. I think we'll just do 2 rows of bushes and 2 rows of carrots because there's no shortage of hay here. So first thing is we need to find if we're on a grid tile. I think we can use a modulus function of x plus y. Modulus 2 should give us a grid. So if we're on 0, 0 will be 0, 0, 1 will be 1, 0, 2 will be 0, 0, 3 will be 1, 1, 0 will be 1, 1, 1 will be 0. Yeah, I think that'll give us a nice little grid. So our first if check is going to be if x plus y modulus 2, and I'm going to use parentheses, not necessarily because we need to, but it's always good to use parentheses as a way to add clarity. If our x and y position added together, modulus 2 is equal to 1, that's going to be our grid position. So the same kind of overarching principle will be here if can harvest. And then we'll go ahead and tap this in. So plant entities dot tree. So if that first condition is not true, we're going to fall back to this, and I need to add a condition here. And now we're going to check based on our y. So if y is less than or equal to 1, this will be carrots. Else, this will be the case of our y position is greater than 1, so this will be our 2 and our 3. We want to do plant entities dot bush, and this should give us plenty of wood. Now, I deleted our setup just so it wasn't extra confusing, but we're still going to need it. I think I'm going to change something here. It won't actually let you plant over an existing plant. Hay being kind of the exception, and then when you get into pumpkins, it'll still do the same thing. Then I'm just using comments here to separate these 2 blocks. Sometimes if you have if statements stacked really closely together, it can look like it's an if and an else, even though obviously that's not what the syntax of the language is. So I like to break things out like this, really show that there's a separation between what this if statement is doing and what this if, elif, and else are doing. You know, really try to make it clear that they're not connected. So now we no longer need to worry too much about planting in the setup run, and it's mostly because I don't want to duplicate this if logic. We'll harvest if we can. If we can't, we'll try to plant. And we know that the plant function won't plant over a crop if it's already there. So we should be good. We'll go ahead and give this a run, and we'll see how it goes. See how it goes. Basically, everybody but me probably saw what just happened there, where I totally forgot to move east and north. And once again, I've put these in the wrong spot, so we'll go ahead and just tap those in. Cool. Programming is a totally different game when you're being recorded. Now that we've added our move functions, like I've said is really important 5 times, and then proceeded not to do, now this should be good to run. There we go. Now we should see every tile is going to get tilled. We're going to plant carrots, and we have our nice little tree grid pattern here. Awesome. Now that'll get us a healthy amount of wood. Let me move my cursor so that's not so annoying. We're going to get a nice healthy amount of wood. As we can see, those numbers are going up pretty quick. Carrots are lagging a little bit behind, but I'm not super duper worried about that at the moment. Yeah, I'm pretty happy with this. Again, our carrots are falling behind for sure, so I think what we'll go ahead and do, we'll just go ahead and let this run for a second. I'm going to actually comment this out. Then we're just going to make this an else, right? So else we're going to plant. Because obviously those trees are giving us no shortage of wood. We still have 700 hay. Really, there's not too much of a reason here to be planting bushes. I said I'm going to leave it commented out because this logic may come in handy as we get to future things. We might want to do a bit more of a spread of things. Or we might be in a spot where we really need some wood. But now that we have it updated, we're going to go ahead and rerun it. And just as before, we should be seeing our full plot getting tilled. And then we have our move east and move north, brings us right back to the origin. So we're good to go there. And we have this nice little grid. And we're slowly bringing our hay back down to more normal levels as we plant more carrots. All right, so we've let this run for just a minute, and it's looking pretty good. I think we've kind of got this grid layout that we want. And I think this is kind of our intended goal for the first part. So I'm going to go ahead and jump over to VS Code, and I'll show you something really cool that this game does. All right, so welcome to my VS Code window. So this is the actual save directory of the game, not this readme.md. That's a file that I made. But if I go to this main.py, you're going to see this is the code we were just writing in the game. So the developer built in this really cool feature where the code you write in the game is actually saved into Python files in your game save. And this allows us to track our code changes and our game state changes using the save.json is a Git repository. So I've gone ahead and I've initialized an empty repository, and I created a little placeholder README file, which I'll update here in just a moment. I'm going to go ahead and I'm going to pull this into the main repository, and I'll get it hosted and everything just in time for the actual part to go live. So effectively what you're going to see is that each part is going to have its own branch in the repository. So you can go and you can see the code that we've added or the code only pertaining to that one video. And you can kind of see how things progress, how we're going to go from this one main.py module into different functions organized into different modules that handle different things that we'll build. Kind of different like routines or things like that. But for now, thank you so much for watching. Hopefully this has been a much improved experience if you're one of the few people that saw the first attempt at this. Hope to see you in the next one. Thank you so much.